Hey guys, this is Mr. Sansoni. Welcome to your October 26th asynchronous lesson. Today is going to be a little integers review. We're going to go through adding, subtracting, multiplying, and dividing. You'll notice that you've been seeing integers over and over and over during the 8th grade year, and they actually never go away. So you want to make sure you understand all the rules for adding, subtracting, multiplying, and dividing. When we're done with this lesson, you're going to be assigned a Delta Math assignment dealing with adding, subtracting, multiplying, and dividing. It's going to be a little timed lesson. So it's a speed drill and an accuracy drill. Before we start on that, I'm going to share out my good thing. The Steelers beat the Titans yesterday. They are now 6-0. So this should be on Monday, October 26th that you're seeing this. So the Steelers played on October 25th. Here we go. Let's look at adding integers first. I started out with number one, making it as easy as possible. So it is possible that you will see a positive plus a positive. So if it's a positive plus a positive, that's stuff you've been doing since early elementary school. And so if I see 8 plus 3, then I'm just adding 8 plus 3, which is 11. So that's one scenario that you could see when you're adding integers. For number two, now we're getting into where we have both negatives and positives. So for the first couple, I am going to we're going to look at visual clues to see why it is what it is. So if I have -5, usually you see negatives written as red. So I have 5 negatives right there. And then I'm going to add to it a positive 7. And 7, when it's a positive, is going to be 7 blacks. So what you notice is you have a bunch of reds, you have a bunch of blacks. The first thing you should notice is you have more blacks than reds, so your answer is going to be positive. But every time you have a positive with a negative, those are going to cancel each other out because they're opposites. So let's use blue. So this negative cancels out this positive, and this negative cancels out this positive, and this negative cancels out this positive. And this negative cancels out this positive. And one more, this negative cancels out this positive. So basically, those right there are gone because they've canceled out. So now you just have to see what are you left with. And so if you look at the original problem, you see that -5, I had 5 negatives, I had 7 positives. So it only makes sense that I have 2 positives or at least some positives left over because I have more positives than negatives. And so now I just say, well, how many positives do I have left? I have 2. So my answer is a positive 2. So when you are adding integers and one is a negative and one is a positive, what you're really doing is you are just taking the difference between the 2 digits. So the difference between 7 and 5 is 2. And then you see, well, do I have more negatives or do I have more positives? Well, obviously I have more positives, so my answer must be a positive 2. Same thing with number 3. Notice for number 2, I started with the negative, I added a positive. Number 3, I'm adding a negative to a positive, so I'm starting with a positive. So we'll do one more where we're going to write out what it looks like. So I have 9 positives. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to add to it 6 negatives. So I'm going to put 6 negatives right here. 1, 2, 3, 4, 5, 6. Okay? And I stack those so that I can easily cancel out my opposites. For this one, I'm going to take a little shortcut because I have all of those because I have 1 positive paired up with 1 negative for each one of those. So all of those cancel each other out. So I'm done with all of that. Okay? So what I have left is I have those 3 positives over here on the right side. So my answer would have to be positive 3. And then the last possible scenario that you could have for adding integers is you could have a negative plus a negative. So let's think about this again. So if I have -4, then I'm going to put 4 negatives. And then it says I'm going to add 2 more negatives. So notice by adding 2 more negatives, there are no positives. So a lot of people confuse this and say, well, a negative plus a negative is a positive. No, that only works for multiplication. So you have to understand which rules work for which operation. So if I have -4 plus -2, they are only negatives. And so my final answer would have to be a -6. So I'm going to have you try on your own those 6 problems. I want you to pause the video at this time. I am not going to pause it. I'm going to continue on, but I want you to pause it at this time. When you are done solving those 6 problems, then I want you to play it, and I want to make sure that your answers line up with mine. So at this time, pause your video. And here I go. I'm going to continue. For all of these, I'm not going to do the visual clues, but I am going to do the visual clues for a couple. So let's look at -7. So if I have -7, I have 1, 2, 3, 4, 5, 6, 7. And then it says you're going to add to it 6 positives. So 1, 2, 3, 4, 5, 6. I line them up so it's very easy for me to see which ones cancel out. So I'm going to collectively say all of these cancel out. So all of those disappear. Everything inside here goes away. Okay? And then you can clearly see that I still have one little red, one little negative left. So my final answer would be -1. Okay? One more. I've got 8 plus -4. So I have 8 positives. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to add to it 4 negatives. So I have 1, 2, 3, 4. I've got it stacked, so I can clearly see that these 4 positives will cancel out those 4 negatives. So all of those disappear. And I'm left with 4 positives. So my answer must be +4. Okay, one more while I'll show you the visual representation, and then the bottom ones will be, I'm just going to do the answers. So I've got -3 plus -6. I've got -3, 1, 2, 3. There's 3 negatives. I'm going to add to it 6 more negatives. 1, 2, 3, 4, 5, 6. You can see that I only have negatives. And so now you just have to figure out how many negatives do you have? Well, you have 3, and then you have 6. So you have a total of -9. So when the signs are the same, then all you're doing is you're adding the digits together. When the signs are different, all you're doing is subtracting the digits and then deciding which one you have more of. Number 2, 4, and 6. So I guess I did the odds for you since I went across. I did the odds for you where you had visual clues. The evens, we're just going to do answers. So I have -5 plus -3. Notice I only have negatives. 5 negatives, 3 negatives. So you have a total of 8 negatives. Okay, here's our best friend right here. This is the one we go back to elementary school, early elementary school, and it's just positives. Positive plus a positive. 9 plus 2. 9 plus 2 is 11. And then the last one, I have 7 positives. I have 10 negatives. I obviously have more negatives than positives. So I say to myself, well, how many more negatives do I have compared to my positives? Well, I have 3 more negatives. So then my final answer is -3. Okay? Adding and subtracting are very similar because the rule for subtracting is you need to copy, change, or you need to add the opposite. So if you do that strategy, use that strategy, then basically you're transitioning your subtraction problem to an addition problem, and we just worked on addition, so it should be very easy. The problem people have is they try to do it without actually doing the copy, change, or they add the opposite, and then they have no idea what they're actually supposed to be doing. So here's what I mean as far as copy, change, or add the opposite. I went through every scenario that you could possibly have with subtraction, and then I did a couple where we have extras because those seem to be the hardest problems for kids. So I have -4 minus 5. So your job, before you even do anything, is to copy the first number. So when you copy it, you do not change it. Then as soon as you see subtraction, this is your first change. You change subtraction to addition. But you could only do that if you change the number behind the subtraction. So this was a +5, and you need to change it to its opposite. So -4 plus -5. Then we go back to our adding rules because it's now an addition problem. So we find, oh, wait, when I'm adding and it's a negative plus a negative, all I'm doing is I'm just adding the numbers together and keeping the sign. So if I have -4 plus -5, let's draw this one out. -4 plus -5, so I have 4 negatives plus 5 more negatives. And so you can see you only have negatives, so your answer has to be -9. Once you change it to addition and the signs are the same, you take your digits, you add them together, and you keep the sign. Let's go down this time. Since I numbered down, we'll go down. Number 2, I have 6 minus -3. So now I have a positive minus a negative. Well, the rule is still the same. I copy the first number. The first number never changes. Whenever I see subtraction, that becomes addition. And then by me changing the subtraction to addition, I must change the number behind the subtraction to its opposite. So the opposite of -3 is +3. So it may look ugly to begin, 6 minus -3, but when you clean it up, you change it to an addition problem, it's the same thing as 6 plus 3, which is actually very easy. Your answer is 9. Number 3, I have 7 minus 9. Now, here are the places where a lot of people get stuck because they just automatically see 9 and 7. They see the subtraction, they say 2. But that doesn't make sense because I'm taking a smaller number and then I'm subtracting a larger number. So I already know that it has to be a negative because if you take a smaller number minus a larger number, it's going to be a negative. But let's follow our rules. I have copy. I see subtraction. I'm going to change that to addition. And then that 9 cannot be 9. It has to change. The only way you can change this is to change this. So -9 means the same thing as plus -9. Now you can clearly see you have more negatives than positives. So your answer has to be a negative. Well, how many more negatives do I have compared to positives? I have 2 more negatives. So my answer is -2. Number 4, I've got a negative minus another negative. I'm going to use my strategy. The strategy works every single time. The goal is to get it to where it's an addition problem so that you can solve addition with the addition rules that you already know. So I have -8. I never changed the first number. When I see the subtraction sign, that is immediately my signal to change it to addition. Cannot forget to change the number behind it. So -2, the opposite of -2 is +2. Let's go back to a visual clue. I've got 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. I have 2 positives. So I only have 2 positives to cancel out 2 negatives. You can see that you have a lot more negatives left over. So now you just have to figure out how many negatives do you have left over. 1, 2, 3, 4, 5, 6. So my answer is -6. If you look, you say, well, that's pretty easy because the difference between 8 and 2 is 6. So if the signs are different, once you get it to an addition problem, you just take the difference between the two digits. The difference between 8 and 2 is 6, and then I know it's a -6 because I have more negatives than positives. Number 5, I've got a negative minus a positive. Same as number 1. This is one of the big mistake areas for students when they're solving integers. I've got -10 minus 5. But if you write it, copy, change, change. And it may seem silly to actually write this out and change it to an addition problem, but you will make so many less mistakes if you do this because you are setting it up and then you can visually see that, oh, it's this addition problem. So instead of -10 minus 5, I have -10 plus -5. Well, notice they are all negatives. I have 10 negatives, and I'm going to add to it another 5 negatives. So your answer is -15. The signs are the same, so I'm going to add these two numbers together, and I'm going to keep the sign. Last one. I've got a positive minus a positive. So I'm going to write it as 4. As soon as I see subtraction, I change it to addition. That forces me to change 13 to its opposite, which is a -13. So 4 plus -13. I have 4 positives. I have 13 negatives. I have a lot more negatives than positives, so my answer is going to be a negative. And then I say to myself, well, how many more do I have for negatives compared to positives? So I take the difference between these two. The difference between 13 and 4 is 9. So your answer is -9. So here are your 6 to practice on your own. At this time, I'd like you to pause the video, solve the 6 problems, and then as soon as you're done with those 6 problems, go ahead and play it, and I am going to continue on. So here we go. I see -8 minus 5. So I'm going to go -8. I see subtraction. I don't like subtraction. I change it to addition. That forces me to change 5 to its opposite, which is a -5. Then I see that it is -8 plus -5. 8 negatives plus 5 more negatives, a lot of negatives, all negatives. So my answer is a -13. Number 2, I have -7 minus 4. Copy, change, change. Once I get it to an addition sentence, notice I again have just negatives. I have 7 negatives plus another 4 negatives, so I have a total of 11 negatives. Number 3, I have -3 minus -9, so I have -3, copy, change. -9's opposite is +9. So -3 plus 9. Now I have 3 negatives. I have 9 positives. I have more positives than negatives, so I know it has to be a positive answer. So then I say to myself, well, how many more do I have? Well, I have 9 positives. I have 3 negatives. The difference between 9 and 3 is 6. So my answer must be a +6. Number 4, 5, and 6, I'll show you what I do when I'm doing a copy, change, change. I've got these numbers sort of spread out a little bit, and I got the symbol sort of spread out as well. So I can do this. I know I don't have to touch the first one. As soon as I see subtraction, I'm going to change subtraction to addition. And then I must change 10 to its opposite, so that is -10. So I did the copy, change, change right there with the original problem. So if you have them nice and spread out like that, you can do that very easily. So I have 6 positives. I have 10 negatives. I have more negatives than positives. So I know my answer is negative. And then I just need to know what's the difference between 10 and 6. And the difference between 10 and 6 is 4. Same thing with number 5. I got it nice and spread out. So copy. So I don't have to do anything ever with the first number. I see subtraction. I'm going to change that to addition. That 3 no longer can be a 3. It has to go to the opposite. So it becomes a negative 3. So I've got negative 2 plus negative 3, negative 2 plus negative 3. They're all negatives. So my answer is negative 5. And then the last one for subtraction, I've got negative 5 minus 1. Copy. I see subtraction. I change it to addition. And then I change the number behind it. Negative 5 plus negative 1. So negative 5 minus 1 is the same thing as negative 5 plus negative 1. They're all negatives. So my answer is negative 6. Multiply and divide share the same rule. And these are actually much easier than addition and subtraction. Your rule for multiply and divide is if the signs are the same, the answer is going to be positive. If your signs are different, the answer is going to be negative. Now notice I put it in several different formats. I got the little X, but we're sort of getting away from the X because now we're getting closer to algebra and we see X as a variable, but you may still see the X as a multiplication symbol. We're going to see a lot of dots. Dots mean multiply. We're also going to see a lot of 2 things pushed together. Those mean multiply as well. So you have all these different ways of showing multiplication. They all mean the same thing. All I really care about is, are the signs the same? If they are, the answer is positive. If the signs are different, the answer is negative. So I have negative 7 times 3. I have a negative times a positive. The signs are different. So the answer has to be a negative. Let's do this. Answer has to be a negative. And then I just need to know what is 7 times 3, and that is 21. Notice this first one is a negative times a positive. So signs are different. The second one is a positive times a negative. Well, same thing. The signs are different. One's positive, one's negative. So the answer has to be negative. And then 4 times 5 is 20. Well, what if the signs are the same? So even though both of these are negatives, we know that a negative times a negative. So here's that rule that some people think works for addition and subtraction. Has nothing to do with addition and subtraction. Has to do with multiplication. If the signs are the same, so a negative times a negative, then the answer has to be positive. And so your answer is 72. And then here's our easy one. What if it was a positive times a positive? We've been working on this forever. A positive times a positive is going to be a positive. So your answer is 36. So I only have 4 of these for you to practice. Pause the video at this time. Write down your problem. Come up with your answer. Once you're done with your answers, go ahead and unpause the video and double check to make sure you are correct. Here we go. Negative 8 times 7, a negative times a positive. Signs are different, so the answer has to be negative. I just need to know that 8 times 7 is 56. Number 2, negative times a positive again. Signs are different, so negative times a positive has to be a negative. 10 times 4 is 40. Number 3, signs are the same. Negative times a negative. Negative times a negative. They're both negative. The signs are the same. So it has to be a positive. So now I just have to remember what is 2 times 9, and 2 times 9 is 18. And then the last one, just a basic fact. Positive times positive. We know that positive times positive has to be a positive. And so 11 times 12 is 132. Here we go. Here's our last set, division. Same rules as multiply. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. You may see it in this format over here on the left with the little division symbol, or you may see it with the fraction bar because the fraction bar means divide. Either way, the rule is still the same. Signs are the same, answer is positive. Signs are different, answer is negative. So negative divided by a positive has to be a negative. 35 divided by 7 is 5. Number 2, positive divided by a negative. Signs are different. The answer has to be negative. 12 divided by 4 is 3. Number 3, 42 divided by 7. They're both positive. Well, 42 divided by 7 is 6. And then number 4, both negatives. Signs are the same. Signs are the same. That means the answer has to be positive. So what is 63 divided by 9? 63 divided by 9 is a positive 7. Your last little set of practice. Try those 4 problems right there. As soon as you are done, go ahead and unpause the video and then check to see if you're right. So pause your video at this time, do those last 4 problems, and then unpause when you are ready to go. And here are the last 4 answers. I have a negative divided by a positive. The signs are different, so the answer has to be a negative. 36 divided by 4, that is 9. This one was a negative divided by a positive. This one's a positive divided by a negative. Still notice that the signs are different, so the answer has to be negative. So 45 divided by negative 9 must be a negative. 9 goes into 45 5 times. Number 3, signs are the same. I've got a negative divided by a negative. These two are the same symbol. So I know it has to be a positive. 27 divided by 3 is 9. A lot of 9s on this one. And then number 4, I've got 99 divided by 11, positive divided by a positive. Signs are the same, so the answer must be positive. And here's one more 9 for you. 99 divided by 11 is 9. So that is your lesson for today, October 26th. A review of integers. Hopefully all of those made sense. Adding, subtracting, multiply, and divide. Your assignment for tonight will be on Delta Math. You have an add, subtract assignment and a multiply, divide assignment. And like I said, it is time. So we want you to be accurate, but we also want you to be able to do it fairly quickly so that you're not worried about integers as we're doing 8th grade math, because integers is a skill that we should already, or hopefully we've already mastered. So good luck on your Delta Math and enjoy the rest of your week. Talk to you soon. Bye-bye.